All right, so this next one, we're actually going to see this pop up again later on in this course, so we're going to deal with it a little bit more rigorously. But I think this is a good one to take a peek at now. So we've got the integral of tangent of x raised to the power of 5 times secant squared x dx. So we definitely don't have any antiderivative formula for this. So we know that u substitution is going to end up being our method that we use here. All right, so the question becomes, what do we want to let u be? All right, so what are we going to choose as our u to take the derivative here? So I would say that we've got some options. You know, maybe let's think about it. If we had let u equal tangent to the power of 5, maybe. Let's just say we wanted to see what that is. Now think about what would be inclined here. Don't write this down because this actually isn't going to be correct. If we had then said, well, our du, to take the derivative of this, we're going to have to do a chain rule. So that would end up being 5 times the tangent raised to the power of 4 of x times the derivative of the tangent, which would then be secant squared x dx. Now notice if we did a u substitution over here and we let that be our u, the only thing that we're left with is secant squared x dx. There's way too much stuff over here to do a clean u substitution. So that would not have worked out. One thing you may have noticed there is that secant squared did pop up from differentiating the tangent, and that's going to lead us to a good choice for you. So maybe rather than letting it be tangent raised to the power of 5, what if we just chose tangent in and of itself, and see what happens when we do that. So if we were to let u equal just plain old tangent of x, that would mean that our du is going to be secant squared of x dx. Now we've got 5 tangents being multiplied here. So if we go back to this integral now, then we're going to have the integral of u raised to the power of 5. And then this secant squared x dx just comes out as our u. And that ended up being a lot easier than we might have thought. So now we integrate this, and we're going to have 1/6 u to the power of 6 plus c, and that just leaves us with 1/6 times the tangent raised to the power of 6 plus c. And then that one is done. You know, another thing you might want to consider as you're working through these is to remember how these derivatives work, and to see if one might be a better choice than the other. So maybe when we were starting off this problem, we thought to ourselves, well, all right, well, if I need to take the derivative of the tangent, you know, that's going to be secant squared, and the derivative of the secant of x, well, that's secant x tangent x. So maybe we would even just start with that and say, clearly this is going to be an easier road to a solution based on the pieces that I have.